Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on RIP. Let's start our part 3.
Let's look into configuring route attribute, exercise number 1. Okay, so assume that you are the network administrator of company A. The following figure show the network topology of company A. Required, first, ensure that R3 prefer the route to network 10.0.0.0/24 with the next hop R2 and perform the configuration on R1. So if you look into this configuration, R3 is in the middle between R1, R2 and R4, R5. So the first requirement is if R3 want to go to the network just behind R1 and R2, R3 can only use R1 as a next hop. It will require R2 as a next hop, but you need to configure on R1. So configuration on R1 so that R3 will use R2 as the next hop to go to network 10. Okay, and the second requirement, adjust the metric of the route from R3 to network 172.16.0.0/23 to 3. So we need to change the metrics to 3 hop instead of 1 hop. If let's say we look into the topology, and we only can perform that on R3. So from R3, you'll notice that we have 10 network having a equal cost on both 10 network using both .11 and .12, so which is R1, R2, and for R3 to go to 172.16.0.0, we have 2 gateway, 192.168.2.1 and 192.168.2.2. Okay, so that will be here. Okay, so this is 192.168.2.1 and 192.168.2.2. So let's look into our topology. So this is R1. Okay, so let's have a look on our interface. So I have 2 interfaces. The gig 00 that is facing the 10 network, the gig 001 that's facing the 10 network. Okay, and the gig 00 is facing the 192 network. Okay, so if I'm going to do a ping to 192.168.1.3, that's a router 3. Okay, so if I go to router 3, and let me do a display IP routing table, and you'll notice that this is the 172 network. 172 network have 2 gateway, as what you can see from here, and 10 also have 2 gateway. So the first requirement is to configure in R1 so that R3 will prefer R2. So here you can see that this is R3. 10 network is the equal cost. Okay, so the equal cost multipath over here is not what we want. We only want a single path, and the preferred one is supposed to be R2, which is this one, and we only can configure on R1. So the configuration have to be done on R1. Now firstly, we are going to configure the IP prefix. So once we are going to use the prefix with using a 10 network in R1, we are going to increase the metric from 1 hop to more hop. In this case, you can actually put 3 hop. So let's look into the solution here. IP prefix, so I say that index 10 permit 10.0.0.0.24 greater equal 24 greater equal 24 less equal 24. Okay, so this is for me to catch the 10 network with the /24 network. Now I'm going to go into the interface gate 00. Okay, I'm going to say that rip metric out. Okay, with the IP prefix. The IP prefix just now I'm used is called 1. Okay, and I'm going to use a hop count of 3. Okay, so let's go to R3 and have a look. So when I do a display IP routing protocol RIP, there you go. You can see that now the router 3 only use gateway of router 2 to go to the 10 network. Okay, so unless that the interface on the router 2 get disconnected, then R3 will use R1 to go to the 10 network with a hop of 3. There you go. So next we are going to look into the second requirement. Adjust the metric of the route from R3 to network 172.16.0.0/24 to 3 and perform the configuration on R3. So let's do it on R3. So we are going to use the command called rip in. So if let's say I go to this 172, you notice that the cost here is 1. So the requirement is that the metric is 3 hop. Okay, so you have to perform that on R3, okay, with a hop count of 3. Okay, so let's do it now. So the one that is actually facing the 172, let me do a display IP interface brief. Okay, that will be a 001. Okay, so this is the one that is actually facing to 172. So I go to the interface gate 001. I'm going to use a command called rip metric in, and I can actually use any number from 0 to 15. According to the requirement, I need a metric of 3, so myself already 1, so I use 2. Okay, so when I do a display IP routing protocol RIP, there you go. So I have a metric of 3. So that is our lab here. In this exercise, we are going to look into controlling the advertising of RIP route. So based on the same topology, we have 2 tasks here. First, ensure that all the interfaces of R4 can only receive route, update, and perform the configuration on R4. So R4, I only can receive the route. So in another word, you are not supposed to send this information to any of the router. Okay, so you cannot send through this interface or this interface. Now, second task is to prevent gate 000 of R2 from sending RIP packet and perform the configuration on R2. So in another word, you are not allowed to send this configuration on the interface. Whereas on R4, you are not supposed to send the interface on both the interfaces. So let's look into the configuration. So this was the earlier configuration. On R1, if we still remember that we have our IP prefix. Okay, so this is our prefix here. So we have the prefix that's being matched. So what I'm going to do is I will go into my interface gate 000, display this. I'm going to remove my metric first so that I will revert back to the original. Undo rip metric out. Okay, then on the R3, I will just undo the rip metric in. So I will go back to the default configuration, display IP routing protocol RIP. Okay, so I'll just wait for another one to come back here. That is 172. So this one came back. Okay, so I just wait for a while for the 172 to come back. So it will take a while for the advertisement. So let's do the first exercise here. Okay, ensure that all interfaces of R4 can only receive route, update, and perform the configuration on R4. You can only receive. Okay, so you can use the command called silent interface. Alright, so you can see that it came back. So now I need to go to R4. So in R4, I can go to the rip number 1, display this. Okay, so this is my configuration. I need to use a command called silent interface all. Right, so once I silence this interface, I'm not able to advertise this. But you notice over here, this one, sorry, this is my R3. So when I do a display rip 1 route, okay, so the advertisement of 172, you can see that this is 36. Okay, this is 32nd. So if I'm going to redo it, you notice that this is 48 seconds. So because that, I start not receiving any advertisement from R4 because I have silenced the interface. Next, I'm going to do the second exercise here. Prevent gate 00 of R2 from sending RIP packet and perform the configuration on R2. Now, because you need to do on only a single interface, excuse me, we need to do on R2. So on R2, we are going to go into the interface gate 000. We are going to use a command called undo RIP output. Okay, so we are going to prevent them from sending out. So this is called output. Enter. So how to check this command is in the action. So again, we just do a display RIP1 RIP, and you notice that this network is .2, 192.168.1.2. So we look into 1.2, you notice that it's already exit 30 seconds. Okay, so this is already more than 117 seconds. So our configuration is working. In R1, okay, so this is an R1, we have nothing here, so we should be able to receive all the messages. So display IP route, protocol RIP, so you can see that I have all the route here. And if let's say I go to R2, I'm going to use a display RIP, and I show you this. Okay, so you can see that over here I have a silent interface is none. Okay, so I have not silent my interface, but I just enable the undo the RIP output. Okay, but if let's say I go to the router number 4, display RIP. Okay, so let's have a look here. You can see that I have my silent interface here. It's actually all. Okay, silent interface is all. Now just now I never silent my interface on all the interface, but rather than I just use the undo RIP output. Let's do a display RIP1 interface, and we are going to look into our gate 000. We are going to use the verbose, and what you can see from here, do you see that the input has been enabled but the output has been disabled? Alright, so this is the command. So I just go back into the interface to show it to you. Okay, so we have disabled the RIP not to do advertisement. So there are two commands over here. One is called undo RIP output, and the other one in the router 4 here is called silent interface all. This exercise we are going to look into controlling the receiving of RIP route. Now based on the same topology, the requirement here is to prevent R3 from receiving route from R4. Now R4 have an IP address of 192.168.2.1. Okay, so anything from 2.1, which is from R4 interface, we are not going to receive. So the strategy is to use a command called filter policy. Okay, and for us to do that, we are going to use the filter policy together with IP prefix. Alright, so let's look into the configuration. So first, we are going to look into R3. We are going to create an IP prefix. Let's have a look on our IP prefix. There isn't have any yet, so we are going to create one. So the command is called IP prefix. We are going to call it prefix 1, index 10. First, I'm going to say that I'm going to deny the IP address of the router 4. So the router 4 IP address is 2.1. Okay, 2.1. Okay, so I'm going to deny 192.168.2.1. This is a host greater equal 32, less equal 32. Okay, but I would like to allow the router from R5, so I need to create a permit statement. Okay, 20 permit any. Okay, so let's do a display IP prefix. So I have both the index 10 and index 20, and the prefix number is number 1. So before I apply this, I would like to show you the default behavior. So when I do a display IP routing table protocol RIP, you will notice that this is exactly just like what the question is. So each of these, I have 2 router advertised to me. So once I apply the filter, the one from 2.1, which is belong to R4, will be filter. Okay, so let's apply the filter now. So I have my IP prefix just now. Okay, now I need to apply the prefix. So I go to RIP. Then I would like to use a filter policy, and filter policy I'm going to use this called gateway. Okay, so gateway, and they'll ask me for the IP prefix. My prefix just now is 1. Okay, so I'm going to say 1, and this is the import. Enter. So let's do a display IP routing table protocol RIP. Alright, there you go. So you can see that the 2.1 has been filtered, and when I do a display IP prefix, you'll notice that it's actually get a hit. Okay, so this is actually being denied. So this is the way on how you can do the filter policy. Let me show you one more time. This is the command, okay, in conjunction with the IP prefix. Let's look into the summary route now. Okay, so this exercise, we are going to perform 2 tasks. Based on this new topology, we have 4 routers here. R1 connected to this network 10.0.0/24 until 10.0.30/24. So we have 4 of this network. The first requirement is to perform classful summarization. So the question expects the student to summarize based on /8 because it's a classful summarization. This is a class A. Now, second requirement is to enable R3 and R4 perform optimum summarization. So optimum summarization on the network 172.16x0. So based on this diagram, you can see that 172.16.00 until 172.16.30. If we are going to make it as optimum, we should do a calculation, and the calculation we were able to get the answer as 172.16.00/22, and prohibit R3 and R4 from learning the summary route. So they want you to use the avoid feedback. Okay, so let's look into this configuration. So this is a blank configuration without any answer. So let me go to R2, display IP route protocol RIP. And what you can see from here is that the 0, 1, 2, 3, okay, so these are the network that I've learned from 1.1. There's router 1, so we are going to do a classful. Okay, so let's do it. Let's go to R1. So we go to RIP number 1, display this. Okay, so there's no summary here. So since they need a actual summary based on classful, we are going to use a summary. So we are going to use a summary, and when we do a question mark, there's one called always. So I'm going to always do a summary. Okay, so when we do a R2, I do one more time. Okay, so you can see that it has been summarized. So just now you see we have the network of 0, 0, 1, 0, 2, 0, and 3, 0/24, and now it becomes 0, 0/8. Next requirement is to enable the R3 and R4, so we can summarize this into /22. Okay, so right now you can see that it's /24. We are getting this advertisement both from R3 and R4. All right, let's go to R3. Okay, so we have to go to the interface. So the interface that is facing R2, let's have a look. Which interface is this? So we have our gig 001. This is the one actually facing R2. So we have to go to the interface, gig 001. We are going to use a command called RIP summary address. So since I'm going to use a 1600 with a 255.255.252.0 because this is /22, and remember the requirement here is that prohibit R3 and R4 from learning the summary route. So we have to use a command called avoid feedback. So we are going to use an avoid feedback. That's on R3. So if I go to R2 and have a look, okay, so you notice over here I have a /22, and that is from 2.1, so I still have .2.2, so that's from R4. So I'm going to go for R4. Okay, all right, let me put it up. Okay, so this is the interface here, gig 001. I'm going to use the same command, rip summary address 172.16.0.0, avoid feedback. That's it. So let's go to R2 to see the result. Display IP routing table. There you go. So we have both the answer over here. So just to recall back on the R1, we are using a command called summary awaits, and in R3 and R4 we use a command called rip summary address 172.16.0.0/22 avoid feedback.
Thanks for watching. Please do not forget to subscribe to our channel.